Hey guys, my name is Ismas. Today we're going to be looking at how to create some basic fluid simulations in Blender and examine some of the difficulties that you might come across when working with MantaFlow, because it has been about, 6 months since MantaFlow was introduced into Blender, but there are still a lot of issues, and the usability of MantaFlow is a bit the implementation of MantaFlow in Blender is a bit difficult to work with or to understand, but I'll try to unravel the mystery behind MantaFlow as we examine some of the basics of using MantaFlow in Blender. So we're going to create this basic fluid simulation, and I hopefully that we can look at some of the most difficult or complicated settings as we're working here, just to get the basics out of the way. So let's dive in and create a new project. We're going to create something simple so that we can cover the basics and not overwhelm ourselves a lot. So let's create the same setup we had. I'm just going to add a simple curve, and I'm going to extrude a bucket out of this. Yes, shade smooth, auto smooth, and then I will just grab this up here. When working with fluids, the direction or the orientation of your normals is very important. So make sure that you check the orientation of your normals as you're working. You can see that these are pointing inside, so I just want to flip them outside. So Shift N, select everything, and then Shift N to recalculate normals so that they look outside. Actually, that looks wrong. They should be the other way around, I think. So this original version was okay. So I'm just going to turn off this, where is that first orientation, and I'm going to duplicate this into a second bucket. Just scale it up a bit, maybe. So this could be glass or something. So and now let's work on the animation before we work on the fluid simulation. I'm just going to use an empty here. The reason I'm using the empty here is just to make it easier for me to animate these here. So I'm just going to go back to this layout. So now for the animation, I'm just going to animate, because I've parented the cylinder or the bucket to the empty. I can animate the up and down motion using the empty. So I can just, it's going up at around here to around there. You pour the fluids for a few seconds, and then you return to the original position, so something like that. And now, so you can see I'm animating the movement of the bucket using the empty, so that when it comes to the rotation, I just animate the rotation of the bucket. So I can start the rotation around here. So it starts up here and then start powering around there. So you can see it. This setup makes it far easier for me to animate than just animating the bucket itself. So something like that. You use fewer keyframes, and you can just duplicate this back here. So nice and simple. Then we need the fluid. For the fluid, we are going to just duplicate this because we want the volume of the bucket to generate the fluid directly from there. So I'm just going to first turn off the keyframes, Shift D, duplicate this, and scale it just a bit, so that I'm going to also turn on random colors so that we can see everything, and then just select the outer ring. The fluid has to be bounded, or it has to be enclosed. The mesh that is going to generate the fluid has to be enclosed, so that Blender can easily calculate the volume. Otherwise it won't be able to do that. So I'm just going to select this edge ring, hit F to make it a volume, a full volume like that. And now the other thing we need to do is set up the physics for this. So I'm just going to select the empty. These are going to be our collider objects, so we can go to the physics tab, and under fluid we can set them as effector, because now if you want the object to be colliding with the fluid, you have to set it as an effector, and make sure it's set as is planar, so that Blender knows that it's closed object, an unclosed object, like you see the bucket. So this also want the fluids to flow inside, not just flow on top of it and then fall off like that. We want it to flow inside here, like enclosed, like you see here. So go to fluids. This is turning into an English class, which I'm not very good at. So let's just stick with Blender. So use planner so that the fluid can flow in. So let me clear this. Yes, is planner. And then the next thing is to set up our fluid. So select the fluid object and then fluid type flow. And the default is going to be small, but since we are simulating fluids or liquids, we're going to set that to liquid. And everything here is good to go. You don't really have to touch anything. And now all we are left with is to set up the domain. The domain is just a boundary that dictates where the fluid is going to be contained. So it has to enclose everything that is going to be added in the simulation. It's going to be calculated in the simulation. So just create a cube and then go to the fluids, set it as a domain. The default is going to be gas. We want liquid because we are simulating water. And after you're done with that, you have to go back to the 0 frame and then hit simulate. Otherwise, if you start in the middle, it won't simulate. You'll have to first go to the last frame and then go back to 0 frame and then simulate. And if you make any changes in your simulation, for example, let's first preview what this has simulated. You can see everything is working exactly as expected, but the resolution is quite low. So to make it bigger, we have to change the fluid domain resolution to something like 62. Okay, and if you start in the middle, the simulation will not work. That's something that is not very obvious, and it can be very confusing why your simulation is not working, especially with the new implementation of MantaFlow, since there are different cache options, and the default is set to replay, which can be very confusing, especially if you're not familiar with MantaFlow or the implementation of MantaFlow in Blender. It can be very confusing. So if you're using the replay type, you need to make sure that when you're trying to preview the simulation, you're simulating directly from 0 frame, so that you have the simulation working. Otherwise, if you start from a later frame, it won't work as great. And if your fluids are going through the mesh, I've found that increasing the time scale helps a bit. So if we increase this to something like 4, or playing with the time scale can help a bit. So, and again, the implementation of MantaFlow in Blender has not been the smoothest, in my opinion, because it's a bit confusing. So you have to do a lot of experimenting to get what works for you in the scenario you're in. And I found that playing with the time scale helps a lot in getting rid of some of the artifacts that might come. And you can see now we're not getting that a lot, except we are still getting a few particles coming through, but I think those were just splashes instead of, yeah. So I think the fluids is also spilling out. So we need to change the animation just a bit. So around here, I can just grab this so that it's a bit backwards, like so. Now let's try to simulate again. Again, if you make any changes and you want to preview them, you have to, I think I set the time scale too high. So let's try something like 1.2. And it can go back. Every time you want to preview any changes you have made, especially in this implementation of MantaFlow. I hope they change this because it's quite confusing. You have to change a value in the domain so to preview any changes you have. So to preview any changes in this implementation of MantaFlow in Blender, you have to first make another change from the changes you want to preview. So we can also increase the resolution to get better results as well. then you have to wait for the simulation to work. But let me reduce this resolution so that we can look at other things we can use in this. So right now we're just rendering the particles, but if you want to render out the mesh, you can hit simulate so that everything is simulated to your liking, and then say let's simulate up to 100. And then if you want to create the mesh, to render out the mesh, you can click on mesh, and that should just calculate the mesh only. But since the particles have already been calculated, it doesn't have to go through that process. Then now you can see that we have that. And the resolution of your mesh is going to be based on the resolution you set for the domain. So the smaller the resolution here, the better the mesh you're going to get. Yeah, so that's a quick run through how MantaFlow works in Blender. And yeah, I hope some of the implementations are changed, especially maybe the default setting for the fluids for the cache could be changed. Maybe we get a simulate button here, up here, instead of fast scrolling down. There are a lot of changes I think that could be made to improve this. Anyway, thank you for watching. See you later.